Good morning, afternoon, or evening, depending on where you are in the world. And thank you for joining the learning experience today, brought to you by Docker. I'm Amanda Razzani, and welcome back to Techstrong Learning. Before we begin, we have an exciting panel ahead of us, but before we begin, I have a few housekeeping notes. Today's event is being recorded, and we will send you the recording after we conclude our live session today. If you'd like to get involved, please use the chat tab on the right side of your screen. For any questions, please direct those to the Q&A box, also found on the right side of the screen. The Handouts tab currently has some additional resources for you, so please check those out. And finally, 2 $50 Amazon gift card winners will be selected from those who were the most engaged in today's session. So thank you in advance for your chats and questions. Let's go ahead and kick off the program. The topic today is how IKEA Retail leverages Docker and Kubernetes to revolutionize machine learning deployments. And with us today is Fernando, the MLOps engineer of IKEA, Yassine, the tech lead, MLOps platform, Sofiane, the MLOps engineer for IKEA, and Mark, the Senior Technical GTM Manager of Docker. Thank you to Fernando, Yassine, Sofiane, and Mark for joining us today. Mark, would you like to take it from here?
Yeah, excellent. Thank you so much for the introductions. As you just heard, my name is Mark Sherwood. I'm part of the Docker Technical Content Management team, and I'm really excited to be sharing the virtual stage with the IKEA middleware and integration team so we can dive into their MLOps journey. I'm sure everybody on the call is familiar with Docker. We've been helping developers accelerate, secure, test, and deploy their environments at an accelerated pace. And today we're going to be looking at how that transfers into the world of ML and MLOps. So we're going to be exploring the ins and outs of the IKEA team's journey. It's going to be guided through the experiences of the team that was just introduced. And before we get started, we'd love to just do a quick poll to figure out where everybody stands in ML and MLOps journey. So we could launch a poll, just take a few seconds to read through those, position where we are, and we'll be able to tune the presentation to the team skill sets. All right. So I think it looks like we should have quite a few people that have already gone through the poll. I'm sorry. So I was going to just really quick introduce the speakers from IKEA's middleware and integration team. So we've got Sofiane, Yassine, and Fernando. Each of these individuals brings a wealth of knowledge from their experience with the IKEA team in this. So I'd love to turn it over to you now, and we'll take it from there.
Thanks, Mark. Good morning, good afternoon, good evening, everyone for the participants from joining all over the world. So I'm Yassine, lead for the MLOps platform. I also handle the DevOps and also backend coding. So join with me are two wonderful colleagues of me as Fernando and Sofiane. So firstly, I would like to thank you guys for joining this webinar. So I hope there is something to take away by the end of this webinar. So yeah. So let's dive in directly into today's agenda. So why a platform for MLOps? Basically, we'll be talking about what made us, to have develop a centralized platform, and then going on with the consumer landscapes. Who are the data personas that are present currently in IKEA, and what is the platform catered for? And then platform construct. We would be walking through the journey of our MLOps platform over here. And then MLOps component. In this session, we will be deep diving on the components, the tools and technologies that we have used while we are developing this platform. And then following up with the demo session, where we will be showcasing you what are the cool things that we did in the platform, and following by a Q&A session. So let's go through and start with our vision. So it's to create a better everyday life for the many people, which means that we strive every day to build better products to make life better for many people. And then moving on, why a platform for MLOps? So let's get into an idea of how can we accelerate ML lifecycle, which means that how can we make sure we are quickly deploying models from ideation to production. This will become essential, and this will become very active when it comes to keeping up with emerging technologies that are going inside the market right now, and also with the competitors as well. And then moving back to standardization and collaboration. So in the organization, there are a lot of people trying to develop a lot of models and trying to deploy in different ways. Now when you want to scale up your models, standardization plays a key role here. And coming to collaboration, it is really very essential when you try to reuse components that you have built in your model, when you are trying to build a model, right? So those components can be reused by other models as well. So that's where the collaboration comes very handy. And then scaling ML. So scaling ML is nothing but you have to cater for a platform which is not only used by only the predictive models or the mathematical models, but also for generative AI models, because right now generative AI models are making a boom in the market. And then ML observability and explainable AI. So this is the core component of the IKEA's MLOps platform, where we try to give observability metrics to the data scientists or the users who can visualize their metrics of the model and try to take a collective decision whether they have to retrain the model or whether they have to redeploy the model. Explainable AI. This is one of the most important feature, because you have to know why the model has predicted predicted some sort of output, and whether you have to also know that whether the model is biased, whether the model is hallucinating. You need to know the answers why the model did this particular thing in a certain way. So that's where the explainability comes into picture. And then security and compliance. So we at IKEA, security is heart of everything. So we take security very seriously. So that's where we are trying to we are complying with all the security guidelines that we are following at IKEA, and also making sure that we are complying to the EU AI Act that will be coming in the coming years. Moving on, let's see like who are the consumers, what is the consumer landscape at IKEA right now, which means what are the data personas at Inca or IKEA, and who are we targeting for. So there are four types of consumers, four type of data personas. Research data scientists. So these are the persons that are who are slightly coming out of universities or models that are trying to come out of the market, and these persons are responsible to take those models and convert them into a real product. That means from experimentation to making out into a real working solution. And then business data scientists. These are the people who are responsible to take a business idea and make that into an ideation. And then citizen data scientists. For example, there are few people who are working on the store and who wants to know how effective was their marketing campaign, or what is the prediction of sales going to be in the coming future or in the coming months. Those are called the citizen data scientists. And then engineering data scientists. These are the people who actually try to code the model and try to deploy the models in the production. These are the different data scientists that we are targeting at Inca. So now the main part is consumer journeys. So we have divided our MLOps component into three main pillars, that is develop, deploy, and observe. So we're going to walk you through more deep dive into all these components. But first, when we try to develop the platform, we always made sure that the platform is headless by design, which means the data scientist can come at any part of the journey. We have not developed a platform in a dependent manner. For example, if a data scientist wants any sort of development environment like Jupyter Playbook along with the GPUs, he can come to the platform and request it and get it. And then let's say the data scientist has his own infrastructure. He has trained the model. And now he's trying to deploy it. He can use only the deploy service. And same goes with observability. Let's say that they have deployed the model in their own project and they want to observe with us. That's where the deploy component comes. So deploy and observe are the two main, my favorite things, because we did a lot of cool stuff making easy for the data scientists to deploy and observe their metrics. We're going to showcase you how easy it is to deploy model right now and observe model right now in the platform. And then, as you see here, platform is not mandatory, but observability for ML is foundational, because because all the metrics should be captured in order to make sure that the model is not biased or the model is not drifted. Those metrics are essential right now in today's world. And then platform construct. This is nothing but, let's see how the ML cycle happens when you try to develop a model. So everything starts with data, right? So you need data to build a model, to train a model, and then to experiment with it. And the data can be in any place. The data can come from data catalog or marketplace. And you have different sorts of data. One is business data and one is operational data. And then you take that data and then you try to develop a model, that is essentially build a model, train a model. So when you're trying to do it, you also need to experiment it, connect to a experimentation platform. This is very essential because you need to know which model suits you when you're using one particular data sets. So that's where experimentation platform comes in. And when you're trying to do it, you also need to use the feature store. There are features that you are trying to register, and that should be published to a feature store. That's where the feature management comes in. And once you have developed or trained a model, so you push it to code repositories along with whatever the packages or whatever the libraries that you have built. So that's where the code repositories and package libraries comes in. So now once you have developed the model, you're going to deploy. Now there is a deployment platform, so where you can do the deployment as a blue green deployment, as a A/B testing, or as a canary deployment. And then comes the inference platform. This is where you actually try to make predictions. This is where you actually try to communicate with the model. So that's where the inference platform is available. And then observe. So as I said, observability is a key component. You need to make sure that you are observing all the metrics that is coming out of the model. Now observability has two types, operational and modelization metrics, which we're going to deep dive in our next slides. And then this entire layer is connected with the management, where the data scientist has ownership, that they can govern with the model that they have deployed. So that's where the ownership lies. So whatever the slides, whatever the components that I have shown you, will be showcasing you a demo as well. This is just to make sure that you are connecting the dots as we go through our platform and our demo. Moving on, doing a little bit deep dive on the develop platform that we have. So at the heart of the develop is an experimentation platform through which you can connect your integrated development environment, that is Jupyter notebooks. And then once you have your Jupyter notebooks, it comes with all sort of packages that needs to be there when you try to build a model. So it will be connected to a centralized experimentation platform, and we have pipelines as well, which we will be making use of to make sure that everything is accounted for. And then if you can also use the integrated platform in order to connect to high capacity computes. Right now there are a lot of you need GPUs in order to build or train your model, so that is also available in the platform. And same goes with experimentation platform and feature engineering as well. So that's the high level of what the develop is. And then moving to the deploy part. Now there are few components in the deploy. So we believe that everything should be logged, because this logging, once we have all the logs, it can be it can be made available, or it can be used to retrain your model in the future, and it can be used to do a lot of things in the future. That's why we believe everything. That's why we believe everything should be logged, and we are also logging everything right now. And then there is task orchestration, which means that you give a data set to different models, and it will try to pick up which is the best model that you can use for this particular type of data set. And then batch inferencing and real-time inferencing. So there are few models which actually requires batch inferencing, such as mathematical models for stock prediction, and then there is time series and regression models. And then comes the real-time inference, where for example, the IKEA app that is trying to do recommendations, those goes with the real-time inference. Now these are all connected with the inference platform, where you try to communicate with the model. We have built some cool features like how the prediction history is happening, what is the input, what is the output, how is the metrics directly dependent to this. And then, as I said, observability is a key feature. So we are capturing two main matrices related to observability. One is operational monitoring, that goes, and then the other is model observability. So when it comes to operational monitoring and why it is needed, we need to log this to make sure that what sort of traffic the model is getting right now. So how many users are using the model, so what sort of CPU or what sort of memory that is the model being utilized, so that if there is higher traffic, you can spike up or you can try to scale your model based on the traffic that you're getting. So same goes with the inference performance as well. How is your model performing? So do you want to retain your model, or do you want to do some bunch of stuff to make it improve? Then comes the model observability, that is prediction history, model explainability, and drift detection. Prediction history is generally makes sense when you want to see, like, for what input, what is the output is your model giving. So drift detection is essential to make sure that the model is not drifting for the new inputs that you have. The data changes all the time, right? So for example, you have trained a model on a bunch of data. So now you're making use of the new data for doing the predictions. So obviously there might be a drift because the model is not trained on the new data. So that's the reason there should be a drift detection that should be there in order that will make sure that there that can identify that there is a drift, and you can retain the model with a new set of inputs that you have. So this becomes an our ML observability layer. And then manage. So we have developed something. The managed platform is developed in something called as Kappa, which is an internal tool or internal design layer. So here we have developed a model registry, which acts as a centralized repository that stores information, and then which is directly depending on the model versioning. So when you try to push a model registry, it also makes sure that it is versioned in a well fashioned manner. And then going with the metadata repository, where you can hyper tune your parameters, training the metadata and capturing the performance metrics. And then model lifecycle management, which means that using this particular component, you will be able to retrain your models based on the drift, based on the explainability, on based on the prediction history. And then last but not the least, access management. So now using this access management, the data scientist or the owner of the model has full control, that he means which means that he has ownership of who the model needs to be shared, who the model needs to be restricted to. And also the model reporting here will give you an overview of what the entire model looks like, who is using what sort of model, how many operations that the model is happening, which user is able to trigger, which user is sending what sort of metrics, what is the input data sent by the user, what is the output data that he got. So basically we are giving an overview reporting of what is happening with the model right now. So this is the overview, high level overview of what the platform is built on. Now I would like to throw the ball to Sofyan, where he will take you, like, what are the components, tools, and technologies that we have used in order to build the platform. Over to you, Sofyan.
Thank you, Yasin. For those who just joined, I'm Sufyan. I'm part of the MLOps team. And I'm sure, guys, you already have a lot of questions, so don't hesitate to drop those in the Q&A section. So just allow me to... Right, so we just saw why building an MLOps platform is important for IKEA. We showed also the business benefits and the urgency as well that come with that. Now, let's see how the platform is built. So any good platform, whether it's for MLOps or for DevOps as well, requires or sets on 5 important pillars. Let's start with automation. That's automation of processes such as deployment, configuration management, and resources provisioning as well. It's to save time, save resources, but also to give our team and other teams a time to focus on more strategic and creative aspects of their work. Scalability, which is also crucial. It's to handle growth and do it seamlessly and efficiently to ensure consistent, reliable user experience even during peak hours. Security is fundamental aspect woven into every layer of the platform. It's not just a feature, it's a commitment to protect sensitive data, ensuring compliance and maintaining user trust as well. We do that by securing coding practice or secure coding practices and regular security audits and robust access control. Observability is also in the core of the platform. Through robust monitoring, logging, and tracing, we gain insight into the performance and the health of the platform. This will enable us to detect issues early, troubleshoot effectively, and continuously improve our system performance. And finally, the platform is only as valuable as it is accessible and user-friendly. So we designed intuitive interfaces, and we always provide clear documentation. We rely also on regular user feedback and iterative improvements to contribute to an overall positive user experience. All those will be part, or those are the pillars of our sustainable platform, and they form the bedrock of the platform engineering efforts. They are not just concepts, they are principles that guide our decision, development, and dedication for this platform. Now, that also won't be possible without a set of tools that we're going to see together. When you talk about the base of everything, Kubernetes and Docker, they contribute to basically all the 5 pillars, thanks to all the features, including orchestration and containerization features that come with Kubernetes and Docker. On top of that, we also use some cloud-native tools, the Grafana stack with Prometheus, Kafka, Cloud Native, Knative, Istio, Keycloak as well. CI/CD pipelines and CI/CD tools are very crucial as well to reduce time to market for us. GitHub Actions, Argo CD, and Terraform, we're going to talk about them. And MLOps platform wouldn't be possible, obviously, without MLOps tools, and that's what we're going to see just after. In some aspects, and sometimes there will be gaps that those tools don't cover. This is where our team will be developing custom application or custom libraries to cover those gaps. That will be with React for the front end, Python for the back end, and also our internal components components library as well. So let's talk about the MLOps tools. Probably the most popular one is MLflow. So MLflow is very known in the MLOps world. It's actually an open source machine learning library that manages the entire ML machine learning lifecycle. We within IKEA, we use it mainly for experiment tracking because MLflow is framework agnostic. It supports various machine learning libraries. There is great documentation and great community behind it, which is very, very crucial for us. When we talk about reproducing machine learning pipelines, tools such as ZenML come to mind. So ZenML actually facilitates the transition from dev environment to prod with minimal or even no code changes. This is very crucial for our data scientists who are in need to move quickly to production to produce value for our end users. We also provide a centralized feature store, which is a dedicated platform that serves as a single source of truth for machine learning features. We know that part of the machine learning pipeline is built-in feature and feature engineering. Those features need to be stored, organized, and served, and Feast will help with that through also and provide also feature discovery and sharing, and also enhance data consistency. Next, our model is ready, our model is trained, it's time to deploy it. And this is where Seldon Core comes to play. So Seldon Core is actually a deployment and management tool for machine learning models. It comes with a lot of features, including model serving, Kubernetes integration, auto-scaling, monitoring, and many more. Seldon and company also provide an open source library called Alibi. So Alibi has 2 components. So once to detect, it's called Alibi Detect, which is to detect outliers and anomalies in data and offering a model agnostic algorithm from transparent insights. Or we also have Alibi Explain, which focus on explaining machine learning model prediction and provide reasons behind decisions. We're going to see both in action and on the demo. And finally, we also have Evidently AI, which is a tool for monitoring machine learning model and produce and generate interactive reports for data quality, data drift, and target drift. Right, so I've seen from the poll that a lot of you are coming from DevOps background. So those tools on the screen wouldn't be unknown for you. So GitHub Actions, Argo CD, Terraform, they all share a common emphasis on automation and infrastructure as a code in the DevOps landscape, starting with Argo CD, which is specialized in continuous delivery for Kubernetes application to produce consistent and reproducible deployment through GitOps practices. We also have Terraform, which serves as a dedicated infrastructure as a tool, allowing the declarative definition and provisioning of infrastructure resources. And finally, we also have GitHub Actions, which facilitate workflow and thanks to its automation and the direct integration with GitHub. This will allow us to have faster development iterations and more secure deployments. Now, everything within the cluster needs to be secure because we have a lot of services. Those services, microservices, and also models. And we need a good way to manage those services. That's where an Istio comes to play. So Istio is a service mesh that provides a way, an uniform way, an efficient way to secure, connect, and monitor services within a Kubernetes cluster. It's offer a lot of features, mainly traffic management, where we be able to manage all the traffic coming in and out of the cluster. This is very crucial. Also, it's offer advanced routing rules, where we can also provide canary releases, weighted traffic distribution, and conditional routing rules based on, for example, HTTP headers or other elements as well. It provides built-in metrics and monitoring for service health. It's also provide tracing, which aid us in identifying bottlenecks and optimize performance in our services. And finally, also Istio enforce Meteor TLS for secure communication between microservices. And it offers as well centralized authentication and authorization system to ensure controlled access and security compliance. Let's see how that's work in action. So we said Istio is deployed as a service mesh to the cluster. It's not enough because it needs as well or to work hand to hand with another tool called Keycloak. So Keycloak is an open source identity and access management. It's manage user identities and access policies. It acts as the sole identity provider that handle authentication, authorization, and user management. So Istio will leverage Keycloak. How? Well, by when a request is made for any service within the cluster or any model. So Istio can enforce authentication by redirecting the user to Keycloak, which will handle the authentication based on configured identity providers. And upon successful authentication, it generates some tokens. Now, those tokens will contain roles, permissions, maybe some attributes, depending on the use case. Istio then will use these tokens to enforce authorization policies, allowing or denying access to specific service from our users. So whatever, if the user is coming from the website of our front end, or is using a development environment, or they are using, or it's actually a remote workload, all of that, they have to come through Istio and Keycloak, and the access will be managed by those tools together. Okay. Now we have seen an overview of the tools that we have within the platform. Let's see how all of that comes together to work in tandem to provide us with value. And we're going to focus about deploy, or our deploy components, which is the tool or the part of the framework responsible of model deployments. And I join Yasin as well when I say it's my favorite part of the platform as well. Because it involves a lot of tools and a lot of mechanisms to make it happen. So I will give you a few moments to take a look at this architecture diagram. So you see some boxes on red. Those are the cloud native, let's say, tools that we are using plus BigQuery. The ones in yellows are the MLOps tools, and the ones that are in green are the custom deployment or the custom development, which consists of either libraries or APIs. Now, it's all starts when a user will come and try to use the FAST API or try to deploy a model on the platform. So it has to go through an API that we call one-click deployment. This API will simplify management of resources within the Kubernetes cluster. So instead of manipulating complex Kubernetes files and manifest files, this API will simplify the creation of those Kubernetes resources. The main one here is Sildon. So this is where Sildon comes into place. So Sildon core provides CRDs, which are custom resource definition on Kubernetes. Those CRDs will help us to deploy models directly to the Kubernetes cluster. So models can be deployed using prepackaged servers. That means that you don't need to write any line of code. You bring your model with the artifacts and you provide the link to your artifacts, and Sildon will be responsible to deploy it, whether it's PyTorch, TensorFlow, Hugging Face, or even from MLflow itself. That's done by the list of prepackaged servers included in Sildon. Obviously, it's still possible to deploy a custom model, and also you will be provided with several more features with Sildon. Now, every Sildon as well will expose operational metrics that will be scraped by Prometheus and shown to our user on the front end, and also for internal use, we'll use Grafana. The model will be deployed. You will be provided with a secured API endpoint. It is secured by Keycloak, and you can use it either from the front end or from, let's say, a remote API or a remote AI application. We're going to see that as well in the demo. Now, once all of that happen, we have as well, or once a user wants to use the model, that will generate what we call a request trigger and a response trigger. This is handled and maintained by Knative. So Knative and the Knative broker will be responsible of collecting those triggers or those messages coming as cloud events, and will be redirecting them to Kafka. So Kafka, which is a highly efficient distributed system, streaming system, is basically the backbone of our messaging system. So like I said, when a model generates a prediction, and the two messages of request and response will be generated, the Kafka sync here is responsible for taking the data from the Knative broker and moving that to a Kafka topic. So in addition, Kafka is also responsible for moving this data to a BigQuery table, where we'll be conducting more analysis and also using Evently AI to generate data quality reports, data drift reports, and also target reports. We also there is also the possibility to deploy a real-time drift detector in the same mechanism for every request generated in the model. And thanks to the second tool we talked about, which is Alibi, we can deploy what we call a drift detector. So that will expose drift metrics that will be also scraped by Prometheus, and eventually will be presented to our user on the front end, where they are able to see if the model is drifting or not in a certain part of time. Alibi is also helpful when we want to deploy an explainable AI model that will help us to explain what's happening within the model and explain every prediction that the model creates. So that will be all for me. And we still have one good surprise for you, which is the demo. And I think it's the fun part, or the will be more fun with that. And I will pass that to my colleague, Fernando.
Okay, thank you, Sofia. Let's go for the fun part, as you said. Well, today I will showcase how we can train a model, test locally, deploy this model, and make some requests. Then we will move on how we can train and deploy a drift detection and explainable AI model for improving observability. For that purpose, we will use a public and well-known dataset in order to focus on the tools and components of the platform instead of the model complexity. The first step in the data science journey is to train a model. To optimize this process, we'll recommend to use an hyperparameter tuning library called Optuna, where we will add some interval or possible value of different hyperparameters. Then Optuna will select what are the best parameters to train the final model. As you can see here, the Optuna will iterate about this solver and these values, and will detect that the best hyperparameter are this solver at this value. So using this parameter, we are going to train the final model. So for the final model, we got very good metrics. So supposing that I'm happy with these metrics, now I want to deploy the model. But what is machine learning deployment? Machine learning deployment can be visualized as the intrinsic process of translating complex designs into tangible and real-world application. At its core, it's about transitioning your model from a developed environment right into production. However, this transformation is not without challenge. For example, scalability, real-time data processing, and provide monitoring by design. Now, let's start the deployment process. The first step is to create a model class. This class will have several functions, like predict, we will receive the input data and will generate some prediction, load, in order to load the model from local or a GCP bucket or any bucket, and the init, which is very common in classes Python. Docker, in this scenario, acts as the container tool that we use in order to ensure that the model will work no matter what is the computer environment. So in order to create a Docker container, we need a Docker file. The Docker file is creating using a cookie-cutter template that we provide for the data science, from which we require a requirement file with the dependencies that they need in order to run the model. Also, in the last line in the code in the Docker file, we will run the Seldon core server, which is required in order to activate the model for make requests. So supposing that I'm happy with this class, I want to test locally before to move about Docker or Kubernetes or any solution. So I will load this class and I will send the first value of the test data into the model in order to generate a prediction. So the model predict the class 1, and this is the data format that I want. What is the next step before deployment? The next step is to build the Docker image and push this image into a GCP bucket where we have access. I have this image already built in order to accelerate the demo, but as you can see here, I push this image into this GCP bucket. So now we are ready for deploying. How we can deploy? We can deploy using both front-end or back-end API. And when you want to deploy a model, you have to include some metadata, like what is the input column that you expect, some input example, what is the output column, output type, who is the model owner, who is allowed to use this model, what are the team that is using this model in order to map the cost, and also some definition about the hardware that your model needs. I will deploy this model later on because I want to show you how can you train and deploy a drift detection and explainable AI model, and we will deploy these three models at the same time in order to show you how straightforward is this process. So I will skip this part. I will cover later on this demo, but now let's talk about drift. Drift in machine learning occurs when the distribution of input or output data at production change from the distribution during training, leading to a decrease in model performance. In order to prepare a drift detection, we will use Alibi Detect. The foundation of this library is rooted on statistical hypothesis testing. So, how do we go about drift detection? One of the crucial elements in this process is the p-value. This p-value helps us in order to control the sensitivity of the drift detection model, which in this case is Kolmorov F- test, as is recommended for tabular data. We will start by creating an artificial drift dataset to simulate real-world data chain. This enables us to evaluate the effectiveness of our drift detection. We will proceed to train the drift detection using the training data. And iteratively, we will iterate for different p-values, and we will see how we can detect the drift in the drifted data, but we cannot detect the drift in the normal data, which is the common scenario in this world. So I'm going to execute this line, and this line will iterate about different p-values, and for different p-values, we are going to generate the drift in the normal data set or in the drifted data set. So the final p-value should be a value that you can see here that detect the drift in the drifted data set, but don't detect the drift in the normal data set. So a good practice in this area is to add bandwidth to this p-value in order to create a robust drift detection. So as you can see, for the selected p-value, we will add like a small limit in order to create a more robust. What is the next step to be deployed? The next step is to save this model locally and then move to a GCP bucket in order to be deployed. And similar to the main model, in order to deploy the drift detection, we need to know some metadata, like what is the CPU that your drift needs, what is the memory limit, what are the number of replicas, who is responsible of this model, what is the drift batch size that you want to use. This number helps us in order to execute the drift not only in a single request. We can wait and execute the drift when we have 128 requests. So we will test later, and we will query the model with normal data and drifted data, and we will compare both scenarios. So we'll skip this part to the last session, and now let's go about explainable AI. Explainable AI trying to explain the decision made by our machine learning model. Understanding why a model has made a particular prediction is crucial for trust and transparency, especially in critical applications. To achieve this, we will employ Alibi Explain, leveraging a technique known as an anchor algorithm. This powerful tool provides intuitive, model-agnostic explanation suitable for various data types, like image, text, tabular data, etc. Our focus here will be on tabular data. Okay, so in order to setting up the explainer, we need to load the model. We need to understand the mechanic behind the model prediction. For example, we need to share what are the expected columns, etc. So when we define these values, we will feed this explainer with the training data. The unique aspect of the anchor algorithm is its approach to understanding the model prediction. It perturbs the input data systematically to observe how this alteration influences to the output. A key concept in our explainer is the anchor. This refers to a specific future value that determines the model prediction. For instance, I'm going to test with the first value. I can see here that the model predicts the, in this case, is the first class because the column petal width is less than 1 and the column sepal length is larger than 5. So in this way, we can know that the model made this exact prediction for this reason with a very good precision, which is very good approach, especially in the upcoming year when we have the AI Act. So similar to the drift detection, we have to save this model and we have to move the model to a GCP bucket in order to be deployed. So now let's deploy this model. For that, we are going to use the frontend. Let me share the frontend. Here we have the frontend of the MLOps platform, where we have a lot of services like develop, deploy, service, data catalog, feature store, digital trust, experiment tracking, observability, and teams. Now let's go for deploy. I have here my model, but let's go into the steps. The first step is to add your team name. This allows us to share your model among your team, to map the cost to your team, etc. Second step involves to define the information about your model, like what is the visibility of your model? It's public, it's private, etc. In this case, it's public because it's for a demo. What is your model name? Some description, and the runtime. As my colleague Sofian said, we support to deploy a model directly using the model file. For example, if I train a TensorFlow model and I save this model in a GCP bucket, if I set here TensorFlow server, just indicating this bucket, I can deploy directly. But in this scenario, as you see before, I create a Docker image. For that reason, we need to deploy using custom runtime. This is the image that I already built. And you can also deploy a Canary model from which you can decide how much traffic do you want to send to this Canary model. And you can compare the performance of both models in production at the same time. The model owner is in order to have more control about the user of the creator of the model. In this case, is me. And you can add some environment variables in case that you need. Right now, I have trained a drift detection and I have moved the drift detection into a GCP bucket. So I will put here what is the bash site that I want and where this detection is executed or is saved. Sorry. Similar to the deploying explainable AI model, this is the kind of algorithm that I use. This is the location of this explainer, and this is the threshold that I allow to drift to this explainer. Similar, we have another parameter called coverage. Coverage is the number of different inputs that the explainer will do in order to take a decision about why this model predicts this class. So next step is to define the schema about your model. What are the columns that your model expects? What is an example of your model? What is the output column? What is the output name? So these are the values that we are using. We expect a tensor as an input, and we expect a tensor as an output. Now, we are going to deploy like 3 different models at the same time, because we have the main model, which is responsible to generate prediction. We have the drift detector. We will take the input data at the same time and is responsible to execute the drift in order to take any action. For example, you might want to retrain the pipeline, or you might want to send an alert to your manager to say, okay, this model is not working well in production. And this is similar to the explainer model. The main idea or the schema of the platform is that you don't have to worry about the combination of how this model interact with them. Using one-click deployment, we will simplify this process for you. So now, you click on next, you can verify that everything is correct, and you can deploy all of this model. I have this model already deployed, but I will show you how can you use. If you go to service, here I have all the information from the models, etc. This is the model that I want to show. This is the description. This is the schema. And here directly, you can test if your model is able to generate prediction. You can change, for example, some values, and you can see how the class may change, which in this case is the same, but let's see. In prediction history, you can see all the history about input and output data that your model is doing in production. You can know who is using the model, what are the classes that your model is predicting. We can share with the data science some reports about the prediction history. A cool thing here is that you see a button called Get Explanation. Using this button, you can understand why this model took this particular prediction. As you can see, this model took this prediction because the petal width is larger than 1.80 and the petal length is larger than 5.10. So this is very useful in order to share or to understand how your model is working in production. And you can do this explanation for other prediction that you have, not only this one. As you can see, each prediction contains a different anchor and a different reason. So moving to observability, we provide some custom graph that we have created, like what are the requests per second, what is the success rate, what is the total number of requests, what is the latency of your model in different percentages. This is very useful, especially for our operation. Here you can see that we also have a panel for drift metrics. You can see if you have drift in production right now. This is real time. What is the distance? The distance is the difference between the data in production in comparison with the data that you use for training. Also the p-value. When the p-value is close to 1, it indicates that you don't have drift, but I will force the drift in the next step. Also, here you can directly take the logs to the model. You can analyze what is happening. You can see you have some warnings, some problems, etc. Even here, imagine that you want to share this model with a member of your team, or maybe it's in another team. So you can type the email here, and I will add my colleague Yasin, for example. I can also remove, or maybe I want to change the model owner. Similar here, we have a button called prediction URL. So now I want to move this model into an application, for example, to generate recommendation for the IKEA website. I have to copy the URL of the model, and by using a token that is provided by Keycloak, I can start interacting with the model. Let's go into the code. Okay. So now this is the URL of my model, and by using this URL, I can send some observations from the testing data, and we can see if the model is able to generate prediction. Oh, I have to execute this slide first, sorry. As you can see, for different data, the model generates a different prediction. So it's working well, it's very fast, etc. But now let's force the drift. In order to force the drift, we are going to query the model using a drifted data set. So in this case, this is the normal data set. Sorry, this is the drifted data set. So let's query this model with these data sets. And we will analyze later if we detect the drift or not in production. As you can see, this model is generating a lot of prediction. Let's wait. In Prometheus, we set up a range for 1 minute in order to have these metrics. So now, if I share again the screen from the front end, you can see that right now I have an alert for drift. And you can see how the distance increase and the p-value decrease, which is an indication that we discovered the drift. You know, the metrics are not the final part. We have set up an alerting mechanism using the alert manager from Prometheus that we can send an alert to the model creator that, okay, you have drift in your model, so you have to take any action. For example, you have to retrain the model, or you have to use another data. So this is a very powerful tool in production because it's very important for IKEA that we control the model that we have in production. We control the data that the model is using. We are able to explain the prediction. So this is just the beginning of this field, but at IKEA, we are very responsible with the best practice in this area, with the security, with the data observability, model observability, everything. So yeah, that's all from the demo part. Let's go for the Q&A.
Awesome. Well, thank you. That was an awesome demo, and I think a really good lead up. We've got some good questions that are coming in. I think one of them that really jumped out to me is sort of right at the top is, how is ML being used in IKEA and what problems is it solving? Right. I think we did a really good job of showing how you're solving them, but just from a high level, thinking about IKEA, what's solved with a really good MLOps platform?
I think I can take this question. So right now, as I said, Previously, a lot of teams are using their own sort of platform and doing a lot of stuff, which eats out most of their time and energy, right? By bringing a centralized ML platform, we can tell the data scientist or the users that, hey, you concentrate on your model, try to make the model better by increasing its accuracy or making its performance more. We will take care of the infrastructure, and we will make sure that your model is up and running all the time. That responsibility would be best. So I think making data scientists more concentrate on the model will help, to lot improve all the metrics or all the um recommendations that we are giving right now.
Awesome. That's great. And just out of curiosity, have you noticed since the platform was available that the use of ML across different teams at IKEA has gone up? Has it made it more accessible by packaging it this way?
Yes. So what we have observed is that the uh, time taken to productionize the model, that has drastically went down. It takes less amount of time to productionize the model. So that was the intent of developing a platform, right? So which makes it easy for all the users or all the data scientists to help bring their models more up and try to deploy it.
Awesome. Great. Another question here is Docker and Kubernetes play a key role. How do these technologies revolutionize or change machine learning deployments at IKEA? And sort of what advantage has this brought? I know it's a bit of a broad question, so just wondering if there's a couple of high level values for Kubernetes and Docker that's made an impact for you.
I think technologies are there to make solutions very easier, to bring solutions that makes life of other people very easy. I think that's where the Docker and Kubernetes come play a major role when it comes to IKEA and developing a platform. So that's what I think. Maybe Fernando and Sofian, if you would like to add more on it.
Yeah. We mentioned how we wanted a platform that provides security, observability, scalability, and all of that. And you can obviously try to do that in the ordinary way, or the, let's say, old-fashioned way. But Kubernetes and Docker provided throughout the years the tooling to make that happen, to make all those pillars easier to have, and also thanks to the community and the support behind all the tooling that's come with that as well. Another aspect is that Kubernetes and Docker provide isolation, which is very important, and also the ability to move all the workload from a place to another. If you want to move it from another Kubernetes cluster, that's possible. You move it to another cloud provider, that's also possible. And all of these basically benefits come together and to support us while building this platform.
Awesome. All right. Oh, I'm sorry. I was on a different, my Q&A tab popped away. Yeah, so I don't know. I know we've had another poll was just launched. We have a lot of questions in here. I don't know what the timing is looks like. Looks like there's a few minutes left. So we might not get around to all of the questions, but I definitely think we can follow up with individuals on these questions as well, because there's some really interesting things that are being asked about where the IKEA team, where are you finding the models you're using? What thought has gone into licensing of those models that are in use? So do we have a few seconds to address that? Or should we can follow up after with that? So I guess just to bring it to a close, because I know we're coming to an end of time, I really want to thank the team from IKEA for sharing this great information with us. We have pushed in the last poll. If you're interested and have additional questions, the Docker team from the technical side would love to connect and do any sort of use case reviews, talk to you about how you're using AI and ML, and just give some feedback as far as some of the questions that are left open in here. I also just want to highlight in my mind the similarities, the parallels I'm seeing with sort of IKEA and Docker. And IKEA helps design and build things quicker, right? We all know that things are using similar parts, and it makes it easier to put them together because we know them, just like Docker and going to Docker Hub and getting the images for these types of projects. And then, of course, IKEA revolutionized shipping and moving around things that you need. I think Docker does the same thing, right? It's in the container world, is making it easy to get the thing that you need, ship it anywhere, and have it run. So I think it was, hopefully everyone in attendance found this exciting and a valuable use of your time. And any questions, please do reach out to our team. We'd love to answer more along the way.
We also dropped in our LinkedIn's. If anyone has any question or want to have a chat about MLOps, don't hesitate to reach out to us anytime.
Outstanding. I would like to thank Fernando, Yassine, Sofiane, and Mark for taking time to join our discussion and share your expertise with us. And a quick reminder that today's session was recorded. Following this program, you will receive an email with a link to access the recording on demand. You can also find the recording on the DevOps website. Just visit devops.com/webinars. Look in the on-demand section and it will be there. The 2 winners of our $50 gift card giveaway will be contacted shortly after we conclude. So thank you for your engagement today, and remember to fill out our post-webinar survey. And I would like to once again thank Docker for sponsoring today's program. And I would like to thank you, our audience, for being with us for the entirety of this presentation. Please take a moment to fill out our post-webinar survey, and we hope to see you at an upcoming Techstrong Learning webinar.
Thank you, everyone.
Thank you.